everyone. We are back with another Blind75 problem, and this is the fifth problem I'll be explaining from in the playlist, and it is threesome. So the question is, we are given an integer array nums, and we have to return all the triplets num of I, j, and k, such that each of the index is not equal, and the sum of the three values is equal to 0. So notice that the solution set must not contain duplicate triplets. Okay, so let's see how we can go about it. Okay, let's look at the brute force solution. How will we find the numbers which sum up to 0? Three numbers. Okay, so one way is we can run a loop, three loops. So the first one starts from here, second one starts from here, third one starts from here to the end. And once this is done, we shift the element and check for the rest of the elements. What is the complexity here? It is order of n cube, because we have to find the triplets. Okay, so we have to note that the solution should not contain duplicate triplets. How can we make sure of that? So what we can do is we can keep the indexes sorted or the numbers sorted and keep it in a set, and every time when we see a triplet, we have to see whether the combination has already been added to the list or not. If not, then add it to the result. Okay, so what is the space complexity? We are not using any additional space. We will be using just some additional variables and all. So it will be order of 1. So it's constant, so it will be order of 1. So this is not an optimized solution, but let's try this. Okay, I'm just writing from like brute force to the optimization so that everybody can understand what is happening here. Okay, so as we said, what we will do, we need n is len of nums. We need an array to store the results of the triplets, all the triplets, and we have to find set of, for I in range of n, we'll start another loop which starts from I plus 1 to n. For k in range of j plus 1 to n, if I plus j, if nums of I plus nums of j plus nums of k is equal to 0, we need to check whether this is already visited or not. So if tuple of, I'm going to sort the list here, number of elements here. So num of I, num of j, num of k, not in visitor. So it is not, if this combination or if this triplet is not been present already, we will add it to the result. Then we return results. Okay, so what did we do? So we used a set, right? So let's try running and see if it works or not. Okay, yeah. Oh, yeah, we missed to add it to the visitor list. Visitor dot add of tuple of I nums of j nums of k. Let's try that. Sorted, that's, oh, okay, sorted is expecting okay, so another one is there needs to be another, okay, yeah, okay, so it passed, but when if I submit it will probably do a timeout. Let's see how we can optimize it. Okay, so if you haven't gone through the two sum solution in LeetCode, I'll tell you how we can do it, and then we'll use two sum to solve three sum. Okay, so we have this particular list, right? What if we sort it? So let's sort it. So minus 1 0 1 2, oh there is one minus 4, okay, so minus 4 minus 1 0 1 and 2. How will we find two sum here? So let's see, we have to find two sum with say sum 0. I'm just taking an example here. It could be any value. How would we go about it? So since this is sorted, we would start with left element from here, right from here. So minus 4 plus 2, minus 4 plus 2, which is minus 2. So minus 2 is less than 0, right? That means we have to look at the right. So we move it to here. So then we'll check minus 1 plus 2. Minus 1 plus 2 is minus 1 plus 2. What is minus 1 plus 2? It is 1. So 1 is greater than 0. 0 is our target. Okay. 1 is greater than 0. That means we have to move to the left. So we'll move here. Then we'll check minus 1 plus 1. What did we get? 0. So we found pairs with 0. So if we move further, we can see that minus 1 is again there. So that is also a pair, and so on. Okay. So what if we use this and to find the two sum? How will we do it? Okay. So what we can do is we can either okay. So before that let's see the space and the time complexity. So what is the time complexity here? We are doing an iteration once, keeping left and the right pointer on either side. So this is going to be order of n. But prior to that, what did we do? We did sorting. What is the time complexity for that? So order of n log n is for the sorting. So the time complexity is order of n plus order of n log n. Space complexity is order of 1 because we are not using any additional spaces. How can we use this to solve three sum? Let's take a look. So I'll reset the canvas and let's write these values here. Minus 1 0 1 2 minus 1 minus 4. So let's sort it first, right? So what did we get? Minus 4 minus 1 minus 1 0 1 2. So what we have to find is find triplets with sum 0. Suppose I start from this number. and we will look at this list for 2 sum. What value should I look for? Find the pairs in this particular list which sum up to -2, so that -2 plus 2 can become 0. And then we'll start from here and look for pairs in this sublist which where the sum is what? Here it is 1, then we'll look for -1 and so on. So this is how we can solve it, right? So we use what we know already, and then then we find it out, right? So what if there are multiple results in this particular 2 sum? In that case, what we have to do is we have to just iterate and append this particular value to the result. Okay, so is there anything else we need to take care of? Yeah, we have to make sure that we don't keep the duplicates. Okay, so let's see how we can implement it, and then we'll talk about time and space complexity. So I'll remove this. So what do we want to do? We want to do a sort. Okay, so let's write 2 sum. Okay, so we get this, then the right value and the target. Okay, since we are just keeping track of the right value here, either this, then it becomes this, and so on. Okay, so left is always 0. Result, so there can be multiple pairs, so we will create a list out of it. So while left less than right, s is equal to nums of left plus nums of right. Okay, and if s is equal to target, what do we want to do? We want to append it, right? So we will append it in the order, like left index first and right index element next. Okay, if s less than target, what if the value is less than target? Then we will increase the left to the right, and else that means we have to reduce the right, and at the end we will return the result. So keep in mind this can contain multiple 2 sums, right? Okay, so let's write 3 sum using the 2 sum code here. Okay, so we sorted the array, and we need an array to store the entire triplets, and we'll keep a set to avoid keep adding it multiple times, the same triplet, because it has to be unique as per the description. So I'm starting from n-1, 1, -1. Okay, so 2 sums is equal to self dot 2 sum of, we are giving nums, and the okay, so this is the I this is the right I here. This is initially I is 2, and we are providing this is the right element. Okay, so we'll pass I -1, and what do we want to see? Like we want to find pairs like 0 minus nums of I. So we want to find pairs in this sublist, which is where the target is equal to 0 minus this value 2, right? So yeah, that is what we have given here. So we might have multiple, right? For 2 sum in 2 sums. So result is equal to, this is an array, right? Array with 2 elements, and we are adding the nums of I to that, so that it becomes a triplet. And we are checking if tuple of R not in visited. So if it is if it is not already added, then we will add results dot append of that particular list, which is res here. Okay, then we'll add that we have added this result. Okay, return results. Shall we try running this? Oh, sorry, yeah, it is result. Okay, so it passes, right? What is the benefit of us starting from the right side? So if you think about it, in the previous brute force, I had to do a sorted list because the order would be different, because we were trying different loops. But here, if you think about it, the last element is going to be always this, and if you find here, we are going to get the left element first, then the right. So if you think about it, the order is same. Okay, so yeah, that is one benefit of iterating from the end towards the beginning. Okay, so let me try submitting it and see if all test cases are passing or not. Okay, so it passed. Let's take a look at the so let's go back to the solution. Let's take a look at the space and the time complexity. So here the time complexity is order of n, right? And here we iterate once, so that is order of n, and each time we call this n, right? So it is order of n square. So the time complexity is order of n square, this is for the iteration only, plus order of n log n. So I think we can we can say it is approximately order of n square if we ignore this time complexity. What is the space complexity? Space complexity, if you what are the additional space complexity that we use here? So we use visited set here to see whether we have already added it or not, right? Okay, so what else? We use some variables and that's it. Okay, so we could say the space complexity would be somewhere at the max, it would be order of n, right? Yeah, in the worst case, and that's it. Okay, so can we do it in a different way? So this is absolutely fine. Let's see how we can use a different technique. So if you remember, in the previous two sum, we used a hash map to see whether a element was already visited, and we were checking it and passing it in order of n. Can we use something similar to that? Okay, we can, right? How? So we could use a similar approach, like using two sum with three sum, but what we will do is we would use a hash map or a set to see whether it has been it is already present or not. Let's see how we can implement it. Okay, so in the two sum, we are going to create an set called visited. It is to look back equivalent to what we did in the using the hash map with an index. Okay, so let's see. So this is I, and we will store it in a something called as result. Okay, so let me start by iterating from j. So while j less than len of nums, so we are iterating. So we are given an index, we start from the next index to the end of the index. So what do we want to find it? So we want to check whether a complement, what would be the complement. Okay, so we have I and j, right? So what would be the complement? So it would be 0 minus nums of I plus nums of j, right? So we can also say like removing this, like minus nums of I minus nums of j, but I'm going to keep it like this. Okay, if complement in visited, that means we got a two sum, result dot append of, what do we want to pass? Nums of I, nums of j, and the complement. So we got the triplet, right? So we have to be careful. There is another way to kind of remove the duplicates. Suppose when we, okay, so if we start from -1 here, okay, then we try to look for let this be a long list or whatever it may be. Okay, so we will get two numbers which would sum up to 1, for example, so that it becomes -1 plus 1, and we add it. What if the next element is also -1? It creates the next same triplet, right? So we can avoid it. How? So we will so when we add it, we will avoid it by using a j loop here. While j plus 1 less than nums of, so we are skipping the duplicate element here and not computing it. This is just a trick to get rid of the duplicate index or duplicate triplets. Okay, so what do? We just run a loop and keep incrementing until this is equal. So we will reach here, like we will not consider this -1 here because it's going to eventually produce the same result, which we do not want, right? So yeah, so that is the trick here. Okay, so we then what we would do, we would add the update the visited with the nums of j and create a j plus 1. So we are not returning anything because the result is nothing but result would contain the triplets. Okay, okay, so let's implement the 3 sum now. So we have results here, we did sort it. Okay, so we are already removing the duplicates here. So what do we do? Okay, so we have for I in range of n, if nums of I greater than 0, break. What is this? Okay, so when we have already sorted this, right? So we cannot find the negative element on the right, for example. So if the sum here is positive, we have to find the values on the right, like two values on the right which is less than 0. Is this possible? No, it is not, because the array is already sorted, right? So we cannot do that. So we tackle that here. And if I is equal to 0, this first element, what would we do for the first element? If it is I equal to 0, or we nums of I minus 1 equal to not equal to nums of I. So this is the same thing that we do. We are checking whether the subsequent elements are same or not. If it is not equal, then that, so we are trying to avoid the duplicate here. So we'll call this cell dot to sum of nums I comma results. But what else do we do? Okay, yeah, so we are, oh, this is nums of, okay, return results. So we are passing results here and keeping, let's try, oh, there's a typo here, okay. Okay, okay, so it passes. Let's yeah, let's try submitting and see if it passes all the test cases. Yeah, it does. So the same way, this is almost order of n, and this is order of n, so order of n into order of n, so it is order of n square. And we are not using any, yeah, we are using a visitor here, so the space complexity can be maximum of order of n, right? Yeah, okay, let's can we do it in another way, maybe? Hmm. Okay, so what if the question was like you cannot sort it? Okay, so what do we do in this case? If you remember, we are using hash set, right? How about we use another hash set to keep track of the duplicate element so that we can skip it instead of yeah, sorting it, right? So there is another approach for that. It is, let's see how we can go about it. Okay, so what do we need here? So we this is just an optional problem, because yeah, there can be situation when the interviewer could ask you, what if you cannot sort the array? Okay, so the result is equal to, yeah, this is the array where we would have the result. So we are creating another one set for storing dupes, and dictionary for storing visitor. Okay, so we are starting from the first value in enumerate of nums. So the I would contain the index, val1 would contain the value here. We are checking whether it is not in dupes. So because we, yeah, if it is in dupe, that means the value has already been used to make that triplet and we should avoid it, right? So we are doing that here. So if it is not in dupes, that means it's a new value. We will add the val1 so that it doesn't, yeah, it gets used in the next iteration. So we got val1, and let's do the second value for j comma val2 in enumerate of nums. What do we want? We just want to store it, do it from the next element, right? Find the next element here, and yeah, so what is the complement? What do we want to see? So we want to check 0 minus val1 plus val2. That is what we want to find out. What if the complement is already existing in the visited list, and in the visitor we are also going to store the index? Then we would append it to the result dot append of, we would yeah, in order to yeah, solve the duplicate, we will store what? Val1, val2, and complement. Yeah, and we need to update the visitor of val2 is equal to I. So this is just to understand that these are the two values that we have taken. Okay, and we return the result. Let's run it. Okay, yeah, this is equal to, let's see. Okay, so there is a duplicate here. What did we do? Mm, sorted off. Val 1, val 2. Yes. Oh, okay. Um, so we have a, let's see. So we have a result, we have duplicates. Mm, okay. Mm, oh, okay. So yeah, we want to add it as a tuple of, yeah. Mm, so let's see what went wrong. Not in dupes dot add of. So we have this val1 which is starting from here. If val1 not in dupes dot, okay, so yeah, it is, yeah, let's see, yeah. So we'll use result as a set, okay, here. Okay, so it doesn't matter how we return it. So just to avoid keeping duplicates, we are using it as a set, and we are keeping it added because yeah, and since we are doing this sorted of the values and keeping it as a tuple in the set, it won't have duplicates. Let's try submitting it and see if it passes. Okay. So yeah, these are the ways how we could solve threesome. I hope this was clear. Please let me know in the comments if it wasn't. I'll try my best to improve it. As I am also new to making videos and taking or talking about this. Um, okay, so yeah, that's the end of this video, and thank you everyone for watching. And let's see again with another problem from Blind75. Thank you so much. Thank you. Bye bye.